Hey guys, how's it going? Welcome to day 28. Today we're looking at functions increasing and functions decreasing, and we're going to continue to talk a little bit more about critical points. Today's video is very, very important. Questions like this come up all the time on the exam, so let's make sure that we are ready to go. Okay, so the first thing I want to talk about is what's true about a function f if it's increasing or decreasing? So let's take a look at a little graph. I think this is easiest to see through graph form first, and then we'll talk about it through functions and solving it without a graph. Okay, so I have some kind of like cubic looking graph thing here, and my question is, on this graph, on what intervals is f increasing? On what intervals is f decreasing? Well, it'll help if I put some numbers in here, so let's try this. Okay, so to figure out when f is increasing or decreasing here, I can tell this by looking at f and see, is f going up or is f going down? Okay, well, we can see that it switches, right? Well, starting on the leftmost arrow over here, I can see that f is increasing, then f starts decreasing, then f starts increasing again. Okay, and it looks like f is increasing, right, on this stretch right here, and then this stretch right here. So I can say f is increasing on the interval from -infinity to -3, union the interval from 3 to infinity. Okay, f is then decreasing on the interval from -3 to 3. Now, there's some question on whether or not we use parentheses here or we use brackets. For infinity, we always use parentheses. Okay? And there's some debate in the mathematical community. The point is, on the AP exam, they'll accept parentheses or brackets. So we're just going to go with parentheses. We can talk about that a little bit in class. But more important, right, it's going to be very rare that they're going to give you a graph of f and ask you when f is increasing. What's more important here is that we see what's going to always be true when f is increasing, specifically related to the derivative. Okay? In those two sections I circled, when f is increasing, what do we know about all of the slopes of the tangent line? Well, if f is going up and to the right, increasing, then our slopes of our tangent line must always be positive. Yeah, I'll use a different color there. All of these tangent line slopes are positive. Whereas if f is decreasing, our tangent line slopes are negative. Okay. Which brings us to an absolutely critical definition that we need to know, okay? Because we don't always have a graph, and it can often be time consuming to create a graph. So what we want to do is relate the function f's increasing or decreasing to the derivative f prime. Okay, these two derivatives, box them and begin to memorize them. I'll create another Quizlet for you guys Those of you who used it probably did quite well on your most recent test. So here's the first thing. F is increasing when f prime of x is positive, or f prime of x is greater than 0. Okay, the reverse then is true. F is decreasing when f prime of x is less than 0. Okay, so those are two really, really, really important points there. So let me show you an example of what I mean and how we can do this without a graph. So I gave you a function f of x. Okay, we don't have a graph of f of x, and our graphing calculator is not available. And I want to know on what intervals is f increasing. Well, what I know for a fact is that f has to be increasing anytime f prime of x is positive, right? That's my definition that I know. Just like with the PVA stuff, okay? Knowing your definitions helps you start, what do I do with this problem? Well, what I need to do is I need to figure out when f prime is greater than 0. Well, the first thing is I don't have f prime of x, so that's what I'm going to have to find first. So I'm going to go ahead and find f prime of x first. Okay, a simple derivative to find. Okay. Now I want to figure out when this f prime of x is greater than 0. This is just like when we determined when velocity was positive or negative, right? To figure out where the derivative is going to be greater than 0, I first need to figure out where the derivative is equal to 0. And then I'm going to do an f prime number line to determine this. Okay, so let's figure out f prime of x equals 0. So this is, in a sense, finding the critical point, right? And I add the 5 over, I get 6x equals 5, and I get x equals 5/6. That is not the solution to my problem. That helps me determine where f prime of x equals 0. Now I want to figure out where f prime of x is greater than 0. So I'm going to do a number line test, a sign test. Okay, but instead of doing it with velocity like we did with direction, now I'm doing it with f prime. And I want to plot all of my zeros. Well, there's only one 0, and it's at 5/6. So what I want to test now is I want to test a number less than 5/6, and I want to test a number greater than 5/6. The easiest number to test of all time is the number 0. So I'm going to plug in the number 0 into f prime, right? 6 times 0 is 0, minus 5 is negative 5. So since 0 is to the left of 5/6, I can put a little minus up here on my f prime number line. Okay? That means f prime of x is negative from negative infinity all the way to 5/6, because that was my only 0, 5/6. Okay, now I need to pick a number bigger than 5/6, so I can pick 1 or 2 or 7 or whatever I want. Any number bigger than 5/6, I'll choose 2. 6 times 2 minus 5, 12 minus 5 is 7. 7 is a positive number. Now I just need to report the interval or intervals where f prime is greater than 0. Right, and I need to justify, and then I'll justify this thing. I can say f is increasing. It goes from 5, 6 all the way out to positive infinity. And my justification, because that's where f prime of x is greater than 0. If I would have asked the exact same question, but instead was looking for where f is decreasing, I would have done every single step the same, but f would have been decreasing on the interval negative infinity, comma 5, 6, because that's where f prime of x is less than 0. Okay. So I can find increasing or decreasing intervals for f by looking at f prime of x, finding the zeros, and doing a sign test, just like we're used to on our position velocity acceleration standard. So this is, hopefully you're finding this nice, because you're kind of already used to doing it. Okay? But it's a new definition. F increases when f prime is greater than 0. F decreases when f prime is less than 0. Okay, next let's talk about how critical points play a role in this. CPs is for critical points. Okay? That's just a reminder from yesterday's video. F has critical points when f prime of x equals 0 or undefined. Now, these critical points are, again, pardon the pun, but are critical because they can tell us interesting features of the graph. For example, let's take a look at a graph. Okay, so taking a look at this graph, this is an F graph, by the way. I want to look for places where the derivative would equal 0, meaning the slope of the tangent line would be horizontal, or where f prime of x is undefined, where I can't get a slope of a tangent line. And I see a total of 1, 2, 3, 4 places. I'll mark them on my screen. Okay, so we see 4 critical points there. The 3 on the left side, it appears that f prime of x equals 0 because I have a horizontal tangent line. The one on the right, f prime of x is undefined because there's a cusp there, and I can't do the derivative at a cusp. It breaks differentiability, like yesterday's video. Okay? Well, critical points can be one of 3 things. They can be a local max, also called a relative max. They can be a relative min or a local min, or they could be neither. So just looking at this, this is a local max right here, because we can see it's the highest point in its little area. Doesn't necessarily have to be the highest point on the entire graph, but in its little region there, it's like the top of a hill. Okay? It's also called a relative max. The test uses both terms. Just be comfortable with those being synonyms. I probably use the word local more often than relative, but I'll try and mix it up and use both. Okay? Are any of our other critical points a local max? Well, yeah, that one on the far right also is. So a critical point could be a local maximum. A critical point could also be a local min or a relative min. AKA relative min. A relative minimum is the lowest point in its little area. Okay? But there's another critical point out here that isn't the highest in its area or the lowest in its area. We call those neither points, neither a local max nor a local min. Oftentimes we see these with terrace points, but it's not the only one. So I want to take a look at these and see if we can find those points, local maxes, local mins, and neithers. I want to see if I can find those without graphing. Okay, that's the goal for the rest of this video. Okay, and we'll try and speed it up a little bit. Let's take a look at our local maxes. Okay, in all of these points, f prime of x is either 0 or undefined. So we have to get a little bit more specific than that to determine what makes a local max, what makes a local min, and what makes a neither. So let's look at the derivatives and specifically how they change. Look on the left side of that local max on the left side of your screen. Okay? Notice how f prime of x, right? Notice how the graph was increasing, hit its maximum, and then started decreasing. That means f prime on this side is a positive number. And then on the right side, f prime became less than 0 over here. Whereas on a local min, it's the reverse. F prime switched from a negative number, right? Negative slope to positive slope. Right. This local max over here, f prime was positive. And then over here, f prime was negative. But what about this neither point? On this side, f prime is greater than 0. On this side, f prime is also greater than 0. So how the derivative changes, or if it changes at all, determines whether or not we have a local max, a local min, or neither. And just like with the PVA stuff, it's going to be really important that you study this and know this definition really, really, really well. Okay? Let's start with local max. Okay? That's this one right up here. F has a local max if f prime switches from positive to negative. F prime is switching from a positive number to a negative number, which means f is switching from increasing to decreasing, which makes sense that something would max out. right? It's increasing, increasing, f is increasing, 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 then f starts decreasing. At that point where I switched, I must have maxed out my height. Okay? That's the third important definition we have today. Local min, then, is going to be the reverse. F prime is going to switch from a negative number to a positive number. Switches. So if f prime switches from minus to plus, that means we have a local minimum. The function went from decreasing to increasing. It bottomed out right when we switched signs at that critical point. Okay? And then f has neither a max or a min if f prime doesn't switch signs. Meaning we could be plus on both sides or we could be minus on both sides. So let's take a look. I want to do 2 examples of this, and then we'll cut it short. Okay, so here's our function. What I want you to do is find the critical points and determine if they are local maxes, local mins, or neither. Okay, so that's my goal. I want to find the critical points and justify them as a relative max, a relative min, or neither. Now, this process is going to be very similar to the process of determining where f is increasing or decreasing. In fact, if we also had that question, we could answer it very easily with the work that we're going to do here. So, first thing I have to do is find critical points. So I have to find f prime of x and determine where it equals 0, or determine if there are any places where f prime is undefined. Now, because that's a nice quadratic there, x is defined everywhere in f prime of x. Therefore, there are no places where f prime of x is undefined. So I can simply set my derivative equal to 0 to find the critical point. I can solve this now by using the RS method. I think about, okay, what 2 numbers multiply to negative 20, but add to negative 8? So I'm obviously looking for 1 negative, 1 positive, and my numbers are negative 10 and positive 2. Which means I get 2 critical point solutions. I get x equals 10, and I get x equals negative 2. Now, if all I was supposed to do was find the x values of the critical points, I could stop there. But I also have to justify whether each of these critical points is a local max, local min, or neither. So I have to do a test because I have to tell how f prime changes at those zeros, or if it changes at all. Right? When I take a look up here at those critical points, is f prime switching from plus to minus? That means I have a max. Minus to plus means I have a min. Not changing means I have neither. So let's go ahead and put them on an f prime number line. I'm going to plot -2 and 10. Now make sure -2 is on the left and 10 is on the right, otherwise you're going to confuse yourself. Okay. And what I need to do now is check numbers to the left of -2, in between -2 and 10, and to the right of 10. And I'm checking them in f prime of x. So out here, I'm going to use the number -3. And again, I like to use my factored form here to test. -3 minus 10 is a negative number. -3 plus 2 is a negative number. A negative times a negative is a positive. And again, in terms of increasing, decreasing, I know f increases then from -infinity to -2. The next number I'm going to check is 0. 0 minus 10 is still negative, but 0 plus 2 is now positive. A negative times a positive is a negative. Now I'm going to check the number 11. 11 minus 10 is positive. 11 plus 2 is positive. Positive times positive is positive. So what does that mean about my critical points? Well, look at how f prime changed at -2. F prime changed, we read it left to right, just like a book in English. F prime is switching from positive to negative. That means, sometimes I do this to like help myself. That means f goes from increasing to decreasing. That's clearly a max. At -10, or sorry, at 10, f prime is going from minus, so f is decreasing, increasing. That's going to be a local min. But I have to write this out and justify it. That's not going to be good enough. So here's what I'm going to say. X equals -2 is a relative max. I'll use the words they used. Because f prime switches from plus to minus. Right? Again, we're switching from plus to minus. That's going to create a local maximum. X equals 10 then is a relative min. Because f prime switches the other way, minus to plus. You can use plus to minus, minus to plus, or positive to negative, or greater than 0 to less than 0. Any of those kind of things work. Plus to minus, minus to plus seems to work easiest for me. Okay? Now, we can graph our original function here and see if that jives with it. So let's do that quick. So I'm going to graph my function. 1/3 x cubed minus 4x squared minus 20x plus 2. On my window, I want to make sure I can see -2 and 10. I'm going to be able to see -2 pretty easily. 10, maybe not so much. And when we graph this thing, here's what we see. I'm going to space this window out. So I'm going to go negative 300 to 300. And what I see is exactly what I thought. Negative 2 should be a local maximum, which it is. Positive 10 should be a local minimum, which it is. And I was able to do that without being able to see the graph. Okay? Last one before we're done here. New function. So here's my function f of x. Again, I want to find and analyze critical points. So finding the critical point first, f prime of x would be 3x squared plus 18x plus 27. I want to go ahead and set that equal to 0. To make this easier, I'm going to divide everything by 3. That's going to give me x squared plus 6x plus 9. Then I'm going to go ahead and do my RS method. What numbers multiply to 9, but add to 6? That would be positive 3 and positive 3. And again, if you want, you can think of this as factoring out that 3. Okay. Either way, it doesn't matter. We get one solution here, and we get a value of x equals negative 3. So that's our only critical point. So what I want to do then is plot that on my f prime number line. And what I want to do now is test numbers to the left of negative 3 and to the right of negative 3. I'll use negative 4 first. So again, you can do this with or without the 3 in there. The 3 is always plus if you want to keep it in there. It won't affect the sign. It'll affect the overall value. Negative 4 plus 3 is negative. Negative 4 plus 3 is also negative. A negative times a negative is a positive. Okay, I'm going to choose a number to the right of negative 3. I'll use 0. 0 plus 3 is positive. 0 plus 3 is positive, and I get positive over here. So negative 3 is a critical point because f prime of x equals 0. But what is going on here? Is x equals negative 3 a local max, a local min, or neither? Well, notice how f prime didn't change signs. That means x equals negative 3 is neither a max nor a min. Because f prime didn't switch signs. Okay, if we go back to our graph and graph that thing, let's take a look at what that graph would look like. Go ahead and graph x cubed plus 9x squared plus 27x minus 3. And look at what we're seeing at negative 3. We're seeing that terrace point. So it's most definitely a critical point, but this point isn't a local max or a local min. It's neither. All right, that's it for tonight. I will see you guys. Ooh, that was long, sorry. I'll see you guys on Wednesday. Talk to you later. 2 chains, bye.